Now, what I'm going to do is, this lesson's very short. I'm going to rocket through it, and then I'm just going to give you the rest of the day. Stop it. I'm tired of asking. First of all, you're so lame. None of you have ever accomplished it once. Why do you keep trying? Shut up. Shut up. Stop it. Okay? Just stop. I'm tired of asking. Okay? In 3 more days, you can waste your life flipping a bottle to see if it'll stand all day, every day. But until then, stop. Okay? Or practice it on your own time so I don't have to listen to but, because you're so lame, none of you have made it work yet. Okay? Stop it. Alright? Just stop. Alright. We're going to rocket through this. It won't take very long. It's actually a very short lesson, even though it takes up a lot of space because there is so many diagrams, but it won't take very long to do. All right. First thing we're going to talk about is naming polygons. Before we go any further with naming polygons, you have to know a polygon is a fancy word for a closed shape. Okay? Closed shape with straight sides. All right? And we name them named by the corners. So if I draw a shape like this, A, B, C, D, we label the corners, not cornered, we label the corners with caps, and we name it by the corners. So this is polygon ABCD, okay? And you go in a circle around. It doesn't matter where you start, and it doesn't matter if you go clockwise or counterclockwise, but you do that. You would not name this ADBC. Understand? You go in a circle. So ABCD, DCBA, anything like that. All right? Everybody cool? Well, I haven't slid it anywhere, Arsh. I'm just...
You're a slow writer.
Everybody good? Okay. So that's all you need to know for naming a polygon, right? Just like we name lines, right? In the last unit. OF, right? Okay. So now we are going to use similar polygons again. In math, it's stupid because it's happening on this not real life page, but it has real life applications that you take from math to your real life. So first thing we got to do is similar polygons, recognize if they're similar, and then how do we use that similarity? Okay? First thing we have to do is recognize if they're similar. Similarity means they are scaled. So you all know that one of these is a reduction of the other one, if they are similar. Now you can look at this and see that all the angles or all the distances are smaller. So it looks like it might be a reduction, but it might not be a similar reduction. Okay? Everybody with me? All right. So first we got to check if they're similar. To be similar, there are 2 conditions. Condition 1. All angles, just the angles, all the angles are the same. But there's a warning there. They must be in the same spot. Okay? So let's check that. Angle A has been given this symbol. Okay? Everyone agree? Yes. It is between the shortest side and the middle length side. Everybody cool? Now come over to here. Angle E has been given the same symbol, so we know they're the same angle, aren't they? Now let's check. Is angle E between the shortest and the middle length side?
Yes.
So it's in the exact same spot, and it's the same angle. Then we check all the rest. Are they all good?
Yes.
Yes. So our angles are okay. That's one condition. It's got to meet two conditions. All right? Now here's where kids get screwed up by this. If I rotate this shape around and I put E over here and I make it look like this, there's my 90, and I put E over here, kids will tell me that it's not similar. 4.5 and 6. Even though it's the same value and it's between the shortest and the longest, or the shortest and the middle. Do you all see that? Rotation doesn't matter. It's relative position, okay? Like right now, Paneet is beside Riley. Even if we were in space, flying around the Earth in orbit, those two would always be beside each other. You understand? Okay. So that's the first mistake that kids make. The rotation screws them up. Okay? The second thing that has to be is this. The side lengths are proportional. Meaning the scale factor works. Now, scale factor is always a fraction, right? Model over original, yeah? Does this question tell you which is the model and which is the original? So who decides? You decide. It doesn't matter, okay? So if I'm going to make 6, if I'm going to make this the original, then 6 would go on top, right? And what would I compare 6 to? 4.5. Because I got to be in the same spot. 6 is between this and the double arc, so I got to compare to the same side. Okay? Everybody with me? That will get me a scale factor. Now, if all of the scale factors are the same, then these are similar figures. So 6 compares with 4.5. What does 12 compare with? 12 compares with 9. And 8 compares with 6. If all those decimals are the same, then these are similar figures. Okay? And of course, if you do the math, you will find that they are. All of these decimals are 1.33. Yeah. Okay?
Did they repeat?
Yeah, it's 1 1/3. Right? Everybody cool? Okay? That's the theory. Now we're going to use it. But first, we're going to make sure you can do this. Are these guys similar? Yes or no?
Yes.
Got to check two things. One, check angles. Are the angles the same?
Yes.
Yeah. Q equals U. They're in the same spot, right? It's between the second shortest and the shortest. Second shortest and the shortest. So Q equals U. T equals X, R equals V, and S equals W. So half of our conditions are proven, yes? Now I got to check the other one. So I got to check the sizes, right? So I just got to compare any two, okay? So what would 3 compare with? 3 over 2, and then I just got to check any other one. What would 4.2 compare with? 2.8. And now I just check if those are the same. 3 divided by 2 is 1.5, yes? 4.2 divided by 2.8, somebody with a calculator check it.
3 over 2.
1.5. So since they're the same, these are similar figures. Everybody good? Okay. Check all this. Are the angles the same? You don't need to fill it in. Just use your eyes. We're saving some time. Are the angles the same? Yep. So we're good. The matching angles are equal. Now let's check the sides. What compares to what?
M and B.
1.5 would compare to 2, right? So I can do 1.5 over 2. Now, since I put 1.5 in the numerator spot and 2 in the denominator spot, what do I do with 2.25 and 3?
Add.
I got to check them both, don't I? So 1.5 over 2 is done. What's the other fraction I need? 2.25 over 3. Please notice, you must keep the same positions. So because I went with the measurement from MNPQ in the numerator spot, I have to do that for the whole question. Cool? Would it work if I went the other way? Yeah, it'll still work. So let's check. What's 1.5 divided by 2? 0.75. What's 2.25 divided by 3? 0.75. Are they the same?
Yes.
So the scale factors are equal. The scale factors are equal and the angles are equal. The parallelograms are similar. Is everybody good?
Yes.
Just got to check them both. Okay? This tells me that the quadrilaterals are similar, doesn't it? So that already proves that all the angles are the same and the scale factors are the same, right?
Yeah.
I want the length of JM. Where is JM?
Right there.
Right here, correct? Do you know that length?
No.
So what do you give it?
Next.
An X,
Yep.
right? Now, let's see how long X is. What is being compared to get a scale factor? I need to compare two sides that are in the same position, yes?
B and B.
That and that are in the same position, aren't they? So I can compare them and get a scale factor, can't I? Does it matter which one is numerator and which is denominator? No, you decide that. I'm going to go with 20 over 8. Now, if these are similar, then the other comparison has to work and be the same, doesn't it? What's in the numerator? 16 or X? Why? Because I can't change the order. I got to keep 16 there. And what goes here? X. Do we know how to solve that? Sure we do. We did that in Unit 3. What do we do? Cross multiply. 8 times 16 divided by 20. Multiply the pair. Divide the spare. And what's the answer? Does anybody know? Abso-smurfly right, 6.4. Okay? Everybody good? It's easy peasy lemon squeezy. See all this over here? This is crap. Okay? You don't need this. You're smarter than that. You are going to find out the length of YZ right here, correct? So, what do I got to put there? X. Do I have to use X?
No.
I can use any letter. Now I got to do my comparison. What are the sides I can compare? I need to look for a pair of numbers in the same position.
1.8 and 3.
1.8 over 3. Is that okay? All right. So what's the other fraction I have then? X over 2, because I got to keep the order the same. Everybody cool? So do that math on your calculator. Meanwhile, I'm going to reverse it. I'm going to do 3 over 1.8 equals 2 over x. Am I going to get the same answer? Multiply the pair. Divide the spare. Do I get the same answer? 1.8 times 2 divided by 3. 1.8 times 2 divided by 3. I get the same answer, don't I? What is it? 1.2. Everybody cool? Now, can you do it with scale factors? Of course you can. WXYZ is obviously a reduction of STUV, yes? Because it's smaller. So I could find my scale factor and then multiply by that. I don't like doing that way. I like using this way better. Everybody cool? Okay. You already know this, right? Right? This is not news to us, is it? So I can skip this, can't I? Just for fun, what's E? 70. What's T, U and T? 55. Cool. All right, now we're going to get to the only thing that makes this hard. Similar triangles are just similar polygons, right? Triangles are special, okay? They only have to meet one condition. So, angles or sides. If it's anything but a triangle, you got to check angles and sides. But if it's just triangle, you can check one or the other. Okay? Everybody cool? So, if triangle ABC, this sign means similar. It's a squiggly equal sign. Means similar. If ABC is similar to DEF, this is what that means. ABC. So I started with A in the bottom corner and I went clockwise. Agreed? So what must be this angle? Is this D, E, or F? D. Where's E? At the top. Where's F? There. Okay? What angle does A equal? D. What angle does B equal? And what angle does F equal? What angle does F equal? C. I changed the order. Does it matter? No. Everybody good? Okay. So now, let's look at this. This is where it gets tricky. Name the similar triangles. So first we got to name them. Does it matter which one we start with? No. Name one of those triangles for me, BA. Your choice. I've already told you how to name polygons. How do you name them?
That is a isosceles.
No. That's the type of triangle it is. Pardon?
DEF.
DEF? Okay. So he goes DEF.
FBE.
So,
EFB.
triangle DEF is similar. Now, you got to name this guy. Name him properly.
ZXY.
Nope. XZY. Why? D is between the longest and the shortest side, isn't it? Right? So D must compare with the angle over here that is between the longest and the shortest side. Had to be X, yeah? And then I went along the longest side to E. So I go along the longest side to Z, and then to Y. Is everybody cool with that? Why was it tricky?
That's nice.
Watch for rotation. Okay? So go. What's the third angle? 180 minus 68 minus 36. So it's 76. I'll help you out. So now, do the angles. A matches what? P, B matches Q, and C matches R. The matching angles are equal. So we know these are similar, yes? As soon as the angles match, we know we're good. Now you got to name it properly. ABC. So what's this guy's name? PQR. Why? Because I went 76 to 68 to 36. So I go 76 to 68 to 36. I check my rotation. Everybody good?
Yeah.
And the last thing we have to do with these notes is apply it. Find the length of TU. That's right there. So what do I put there? X. Now look for my pair. What's the only number I have in the big triangle? 6 over what? What does 6 compare to?
2.
Why? They're not in the same spot. This guy's on the left, this guy's on the right. But it's between the dot and the U, the arc. Okay? So 6 over 2. Now what goes on top? X or 3? Why? Because we use the 6 first, right? So it's X over what? 3. Do the math. 3 times 6 is? Divided by 2 is? 9. So X equals 9. Is everybody cool with that? Now, I just want to show you just one more thing. Can I do this with scale factor? Yes. If I do 6 divided by 2, I get a scale factor of 3, yes? Which means every measurement on this little guy must multiply by 3. 3 times 3 gets me 9. Cool? What if I go the other way? What if I say 2 over 6? That gives me a scale factor of 1/3, yes? Which means I take the bigger number and I do 3 divided by 1/3 and I get 9, which will get me the same answer. Everybody good? All right, practice this last one and then you're done the course. Most of this is garbage, yes?
Yes. We're done with the course.
I just want answers. I gotta find XV. Where is XV? Right here, yeah? So there's my X, cool? What are the matching sides? FH, which is what? FH and XW, so I got to compare 10 and 2. Does it matter which order I compare them in? No, as long as I do what with that order? Keep it. So what is the little one? What's going on top? 20 or X? 20 over X. Do the math. What's 20 times 2?
40.
What's 40 divided by 10? So XV has a length of 4. Now the last thing you got to be able to do is name them. FGH, X,
Oh, sorry.
XVW. Everybody got it? Okay, I really shortened that down, right? because I'm starting to trust you. Why, I don't know. So you got the rest of the day